Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to start by removing the 16 and multiplying it by the 25, and you'll have x squared minus 40, x plus 400. And then the two numbers you're going to use are negative 20 and negative 20, so make sure you replace the 16 in front of your x. Both of these will reduce, and so we'll have 4x minus 5 times 4x minus 5, which you can write as 4x minus 5 squared. Okay? For the math knowledge question, Tricia ties her dog to a stake using either a chain or a leash. The chain allows movement 20 feet out, so to find the area that the chain would allow, we would say pi 20 squared, and if you multiply that out, you'll get about 1,256. And then for the leash, the radius of the circle is 15, and so your area would be pi 15 squared, and if you multiply that out, you'll get about 106.5. And so if you subtract those, you get almost 550. So that would be your answer there. So today we're looking at lesson 81, graphing and solving linear systems, and then we're also going to look at lesson 88. So hopefully you'll understand how to graph and solve linear systems, and also graph and solve linear inequalities. The inequalities part will be lesson 88. So a system of equations is a set of two or more equations that have two or more variables. We dealt with systems of equations last year. Frequently they looked like this. And it said to solve for x and y. And then towards the end of the year, we had equations that had x, y, and z, and we had 3 of them. But those are examples of systems of equations. So a system of equations can be solved algebraically or by graphing the lines. And we did both methods last year. Algebraically, you can do by substitution or elimination. And then by graphing, you just graph your lines. So we're going to solve this system algebraically. In order to do that, they are both y equals, so we're going to set negative 2/5 x minus 5 equals 2x plus 7. I'm going to multiply by 5 because that's my common denominator here, and so I'm going to have negative 2x minus 25 equals 10x plus 35. I'm going to subtract the 10 to make it negative 12x and add the 25 to make that a 60, and if I divide, I get x equals negative 5. Then I can come over here and I can substitute the negative 5 in for my x value. So 2 times negative 5 is negative 10, plus 7 is going to be a negative 3. So our answer is going to be negative 5, comma, negative 3. And you need to make sure to write it as an ordered pair. Okay? So that'd be how you solve that algebraically. For this one, we want to solve it by graphing the lines. So the way that you do that is to graph both lines. So this is a y-intercept of a 3. And we're going to go down 1 and to the right 4. I can't go to the right 4 more, so I'm going to go up 1 and to the left 4. Okay, and then you're going to make your line. Make sure that you put arrows on the end of your line. You need to make sure you have arrows on your lines, okay? So there's the first one. And then the next one, I'm going to go down to negative 6. I'm going to go up 2 and over 1. And I'm going to keep going. And so that would be what they look like if you graph them. And now to solve it by graphing, you want to know where they intersect. Well, they intersect at this point right here, which is 4, 2. Okay. Looking at the next example, we want to graph this system to determine if there is a solution. So for the first line, we need to solve it so that it's y equals mx plus b. I'm going to start by distributing the 3. After that, I'm going to add the 2, and so I'll have y equals 3x minus 1. So to graph that, I'm going to go to negative 1, and then I'm going to go up 3, and over 1, up 3, and over 1, or down 3, and over 1. And so now I'm going to graph my line. Okay. For the next one, I'm going to do it in red. I'm going to start by subtracting 2. So I'm going to have negative y equals 3 minus 3x. And then I'm going to have y equals negative 3 plus 3x. If I need to, I probably should, I'm going to put it into the correct form. So 3x minus 3. Just switch these two terms around. So we go to graph it. And we have a slope of 3, so up 3 and over 1. And then we're going to graph our line. Okay. And then for the last one, it's already in y equals mx plus b form, so we're just going to go up to 5. And then we're going to go, we can't go up 3, so we're going to go down 3 and to the left 1. And make sure that you're putting arrows on the ends of your lines. Don't just draw your lines and not put arrows. You have to make sure you put arrows on the ends of them. Okay? So it says to determine if there is a solution. Well, the solution is where they intersect. These 3 lines never intersect because the slopes on all of them is a 3. They have the same slope, they're parallel, so there is not a solution because they don't intersect. Okay. Looking at this next example, a marketing research firm is trying to determine the optimum price for a product. The supply of the product is represented by the equation y equals 3x minus 50. The demand is represented by the equation negative 7x plus 300, where y is the price of the product and x is the quantity. What is the optimum price of the product? And how many units of the product will the firm sell at this price? So optimum price is where the supply and the demand are the same. And so we need to figure out where do these two equations equal each other. Well, where does 3x minus 50 equal negative 7x plus 300? Add the 7 to make that a 10x. Add the 50 to make that a 350. And so my x would be 35. And then if I multiply 3x, so 3 times 35 minus 50, I get 105 minus 50. So my y value is going to be 55. So what is the optimum price? Well, y is the price of the product. So my optimum price is going to be 55. That'd be for the first question. And then how many units will they sell? X is the quantity, the number. So they're going to sell 35 of them at that price. And so that would be your answer there. So let's try these practice problems. Y'all pause the video and work them out, and then unpause the video once everyone is finished. So we're going to have 2/3 x minus 8 equals 1/4 x plus 2. We're going to multiply this by 12, and so we're going to have 8x minus 96 equals 3x plus 24. So I can subtract 3x to make that a 5x, and add the 96 to make that a 120. And so my x value is 24. Then I'm going to come to the second equation and plug it in. 1/4 times 24 plus 2. So 1/4 of 24 is 6 plus 2 is going to be 8. Sorry, 8. And so you're going to write your answer. It's an ordered pair, 24, 8. For the next one, we want to also solve it algebraically. So we're again going to set them equal to each other. And so I'm going to multiply by a 6 this time. So I've got a 3 and a 2. So this is going to be negative 4x minus 18 equals 3x plus 12. I'm going to get negative 7x equals 30. And so my x value is going to be negative 30 over 7. And then I'm going to plug that in to this equation here. So y equals 1/2 negative 30 over 7 plus 2. So half of negative 30 over 7 is negative 15 over 7. And then 2 we can write as 14 over 7. And if you add those together, you get that y equals negative 1 over 7. So when we write our answer, you write it as an ordered pair. So negative 30 over 7, comma, negative 1 over 7. And so this would be your answer there. Okay? Looking at the next practice problem. See if you can solve it by graphing, and then determine if there's a solution. So we're going to go up to 4. Then we're going to go up 3 and over 1. And we can go down 3 and to the left 1. And so now we're going to graph our line. And then for the other one, we're going to go to 8. And then we're going to go down 1 into the right 1, down 1 into the right 1. And so that's what your two lines look like. And they intersect at this point here, which is 7, 1. So that would be your answer. For D, determine if there is a solution, and if not, explain why. On these, the slope is negative 2 and negative 2, which means that they are parallel. And so since we have parallel lines, that means that there is not a solution because they do not intersect. So no solution, they're parallel lines, they do not intersect. Looking at the next practice problem, the supply curve for a product is represented by y equals 2x plus 20, and the demand curve for the product is represented by y equals negative 1/2 x plus 80, where y is the price of the product and x is the number of units sold. What is the optimum price of the product and how many units will be sold at that price? So if we're looking for optimum price, we're going to start by setting the two equations equal to each other. And we're going to multiply by 2 because that's our denominator here. So we're going to have 4x plus 40 equals negative x plus 160. So add the x, you'll have 5x, and subtract the 40, you'll have 120. And so your x will equal 24. We're going to do 2 times 24, which is 48, and then plus 20. So our y value is going to be 68. And so the optimum price is $68, and the number that will be sold at that price is 24. Okay, so that's lesson 81. Now we're going to look at lesson 88, graphing and solving linear inequalities. I do want you to do this on a separate sheet of paper, so y'all go ahead and get out another piece of paper to do these for this lesson. So we're looking at linear inequalities. We're going to start by solving the linear inequalities for y. So you do these almost just like you would with an equation. We're going to start by adding the 4x. So we'll have 6y is less than 4x plus 9. Then we're going to divide by 6. So we get y is less than 4 over 6 is the same as 2/3 x. And then 9 over 6 is the same as 3 over 2. So this would be how you would solve it for y. For the next one, we're going to start by subtracting the 3x. So we'll have negative 4y is greater than negative 3x plus 12. Then you're going to divide by negative 4. And when we divide by a negative number, this sign has to switch directions. So now it's going to be less than 3 over 4x minus 3. So you have to remember that when you divide by negative, you switch the sign. Not when you divide by any number, just a negative number. Not when you subtract the number, only when you divide by a negative. Okay? Looking at example 2, we want to graph the inequality. So for these, you're going to start by graphing them very similar to how you would graph a line. So we're going to go to our y-intercept of a 1. We're going to go up 2 and then over 3. Up 2, over 3. And then I'm going to come back and go down 2 and over 3. Down 2 and over 3. Now, instead of just drawing a line, on this one, since it's a greater than and there is no equal to, we make our line by doing dots or dashes. It is not a solid line, okay? And so now, y is greater than this line. So greater than means that it's above. The stuff that's above is in this region here. So all of this would be the stuff that's above. And so that'd be the answer for your graph there. Okay? But you have to make sure you have a dotted line here, not a shaded line. For the next one, we go to negative 2, and then we go up 3 and over 1. And then we can go down 3 and to the left 1. On this one, we're going to have a solid line because we have this or equal to. So you do a solid line when you have an or equal to. Okay, and make sure you're still putting arrows on the end of your lines. And then it says y is less than or equal to. So less than the line is below it. So below the line is down here. So now we're going to shade this area here. And you don't have to make it look all pretty. You can see it kind of looks like a kindergartner shading mine in, which is fine. You just have to shade it in. Okay? Looking at some practice problems. Y'all try these. Pause the video, and then once everyone's finished, y'all unpause it and check and see if you got them correct. So we're going to start by adding the 2x. So I'm going to have negative 4y is less than 2x minus 8. Divide by negative 4. So that's going to be y is greater than negative 1/2 x plus 2. Okay, and so that'd be how you solve for y. For this one here, we're going to go down to negative 6. Then we're going to go up 2 over 1. Up 2 over 1. And so that's going to be our slope. We are going to have a solid line because we have an or equal to. And so make sure you put your arrows on the end of your line. And then it's greater than. So that's this whole region here. Okay? So that's what it would look like. For this next one, it's not solved for y, so we need to start by solving it for y. So 2y is greater than 8 minus x. And so divide by 2. Y is greater than negative 1/2 x plus 4. So we go to 4, and then down 1 into the right 2, down 1 into the right 2. Whoop. And then we can go up 1 into the left 2. On this one, it's not or equal to, so we're going to do a dotted line or a dashed line. Either way that you think of it is fine with me. And then we're going to put arrows on the ends. And then we are greater than, we are above the line, so that's all of this region right here. Okay? Looking at this practice problem, we're going to try it and then unpause the video and you can check your answer. So your equation is going to be negative 4y is less than or equal to 6x plus 8. So if you divide by a negative 4, it's going to be y is greater than or equal to negative 3 over 2x minus 2. So when we go to graph it, we go to negative 2, and then we go down 3, and to the right 2, or up 3, and to the left 2. Since it's an or equal to, we do put a solid line here. Okay, and then it's y is greater than. So above the line, that's all of this region. And that would be your answer there. Looking at the challenge question for today, see if you can figure out what inequality is shown by the graph. All right, so for this one, you're basically looking for the equation of this line, and it's y. I'm going to leave a space because I don't want to figure out my inequality right now. But the slope is down 2 and to the right 1, so a negative 2 over 1, so just negative 2 x, and then our y-intercept is a positive 2. And then it is or equal to because the line is solid, it's not dashed. And then it's all of this area down here, so that is below the line, so y is less than or equal to negative 2x plus 2. So that's how you deal with systems of equations and inequalities. Hopefully you understood how those work. Your homework is problem set 81, 1 through 30. So make sure you do those tonight so we can go over any questions you have tomorrow.